Well, now I will show you how the project works. So in order to do that, we can take a look to this table. This table is the ROM that is into the VPGA. We can see that, for example, if we choose the address 0, we are going to get the value 0. If we choose the address 1, we are going to get -0. If we get the number 7, we will get minus, or none, not a number. And well, we are going to, I will show you some multiplication. For example, we are going to take with the first 3 switches, we are going to choose the operand 1, and with the second 3 switches we are going to choose the operand B. In order to do that, well, for example, we are going to choose, I don't know, this, for example, 3, the position 3, that is 5.5 times 6, 7.5. So first of all, well, I have the multiplication here. 5.5 times 7 is 116.25. We are going to convert this value here. This value should be this result. So now we will show you here in the board. First of all, we are going to program the VPGA. So have the programmer. So I'm going to start. Well, it's on. So with this button I choose the operand B. With this button I choose the operand A. So as we said, we're going to choose the number 6. That means is 6 for the operand B and 3 for the operand A. Yeah, it's 3. We are going to check in order to see if that correct. Well, yeah, number 3, number 6. So the result must be these values and bits. So with this button I choose one operand or the other one operand, the other one operand, the other one. And with this button execute the floating point multiplication. So we can see here this line indicates the ready signal, and the last 4 bits indicate the errors in case that there could be errors. So we're going to see that the result is this one. So this is the most significant bit, and this is the last significant bit. So we can see that is 0 1 0 0 0 0 1. So the result on the web page, we can see that is 0 1 0 0 0 0 1 0 1 1. So this is correct. So another important feature is the detection of not a number or zeros. So how we can do that? Well, we are going to choose one address that is not allowed or that has a wrong value, for example 0, or not a number, that is, if you remember in the ROM table, is the position 7. We go to the quarters, the position 7 is not a number, so the value that is allocated is in the operand B. If you see, there are many ones, so when we execute the multiplication, it's returned 2 bits, 2 LEDs on that indicate that there is not a number in the register B. And we can see also that the result is 0. So if we want to check, for example, for 0, it's the same. In this case, well, we have not a number and 0. So when we execute the multiplication, it returns not a number in one register and one operand, and this indicate that in the other operand is a 0. The same for minus 0. If we put minus 0, that is the other one, we can see that the LED green one is turning on. That means that there is an minus 0 like operand. We can do the same for both registers. So now we can see that I choose the address 45. So one register is this and the other register is just only minus 00, so we can see that in one operand we have one error. If I choose minus and I show it's the same and I execute, I will get an error. So otherwise, if I put another number, well, and I execute the multiplication, here is the value that is allocated and here launches the multiplication, and well, we will get the result. We can do the same, we can check with the web page if it is correct, but well, it is correct. So well, that was the demonstration of the functionality of how the project works. Thank you very much.